Hello student, myself Melisandla, and again today we solve the example of Macaulay's method, and in today's session we take a new beam, and that is our overhanging beam. Okay, now first of all start with this example. We solve this example. In every example we read the data properly, and then we solve one by one with use of Macaulay's method. Okay, here read the data. In data that for a given beam shown in figure, calculate the deflection and slope at the free end by Macaulay's method. And here the value of Young's modulus is given. E is equal to 2 into 10 raised to 5 Newton per mm square, and I is equal to 5 into 10 raised to 8 mm raised to 4. Okay guys, in first starting example the value of EI is given, but in this example value of E is given in Newton mm and value of I is in given mm. Okay, in starting example if you remember, the value of EI is given, that is in kilonewton into meter square, but here the values are given in Newton mm and mm. Okay, what is the effect of this unit in find out slope and deflection? It is I will explain you at the last point when we find out slope and deflection at free end. Okay, now here our given beam is overhanging. Data in this notation is no mention, so that first of all write down this is A point, and here we take this is our B point, this is under the pointer C point, and this is D point. Okay, now first of all find out support reaction, because again step of Macaulay's method, taking moment about A with respect to reference point. We find out taking moment about A point. Okay, and compare this moment anti-clockwise with clockwise. Now RB is given, this is our support reaction RB, and about A distance is equal to 5 into 4, right here RB into distance 9 meter. Okay guys, this is the type of loading. This is UDL. UDL is given like this way, and this is also, this is the sign of UDL loading. Okay, now first point load is given 60 into 4, that is our clockwise 60 into 4, and second UDL is given in entire span, and what is the moment of UDL? Load into distance. This one is 4 plus 5 plus 2, that is 11. 11 into 11 by 2. Now RB is equal to, after simplifying we get reaction at B is equal to 93.88 kilonewton in up direction. Now find out RA. RA is equal to total vertical load. This is the short form of vertical load. Okay, V means vertical, L for load, minus our support reaction RB. Now what is the total vertical load of this given overhanging beam? That is, first load is our point load 60, and second UDL is equal to load into distance 10 into distance 4 plus 5 plus 2, that is 11, and support reaction RB we just find out, that is 93.88, and after simplifying we get RA is equal to our answer 76.12 kilonewton, and that is plus in up direction. Now mention the value of the support reaction. This is our first support reaction 76.12, and value of RB that we find 93.88. Now according to Macaulay's method we have to mention this x and consider this is as distance x to make a equation of moment. Now next step, make a moment equation M. Okay, this support reaction is rotate clockwise direction according to this section XX 76.12 into distance x. Now this is rotate in anti-clockwise direction. Right here at left hand side clockwise plus and anti-clockwise moment is minus according to rule of Macaulay's method. Now 60, then total distance x, and left side the distance remaining, that is 4 meter. Now this UDL is given on entire span, so that again 10 is rotate anti-clockwise direction with respect to axis pointed. So 10 x and x by 2. Now in overhanging beam, look at this, section x is given, and within this left hand side this support ration also considered. In simple supported beam, last support ration B is not considered, because at that point we consider the section, and in this what will be happen? In overhanging beam we take a section on last point and this support ration RB within section, so that we have to count the moment of this support ration also. Okay, in overhanging beam particularly we take care about this both support ration. Now this RB is rotate as a clockwise. Now take RB is equal to plus, and reaction RB is equal to 93.88 and distance left x minus 9. This is the equation of moment for overhanging beam. Now our equation of differential EI d square y dx square is equal to minus m. Change the sign of this equation. First is positive, minus 76.12 convert into negative. Second, point load is anticlockwise minus, take plus minus 4 and UDL is equal to 10 by 2, that means I divide 5 and this will be minus, convert into plus 5x square. Then this support reaction RB is also positive, considered into minus, that is 93.88 x minus 9. Okay, now in next step we integrate this term. Okay, after integrating this term, first EI d square y dx square, integration of this term is dy by dx. Right here, integrate this term. Okay, dy by dx, and that is minus 76.12 and integration of x is equal to x square by 2 plus add constant c1, then 60 and x minus 4 raised to square by 2. Next, plus 5 x square x cube by 3 minus 93.88 x minus 9 square by 2. This is the equation of slope. Now in next, again we integrate the above equation with respect to okay. Now first of all we write here our first equation EI, again I am writing down here EI dy by dx is equal to our first minus 76.12 x square by 2, then our constant c1, in next term 5 x cube by 3 plus 60, then x minus 4 square by 2 and minus 93.88 x minus 9 square by 2. Okay, and this is the equation of slope 1. Now what will the next step? Again integrate, right here, again integrate this above equation, again integrate it. Now what is the integration of dy by dx? That is y is equal to minus 76.12 by 2 and integration of x square is equal to x cube by 3 plus integration of c1 c1x plus c2 and again our constant 5 by 3. There is no need to divide it, x raised to 4 by 4 and 60 by 2, that is equal to 30, 32 is 60, right here 30, and integration of x minus 4 square, that is cube by 3, minus 93.88 by 2 and x minus 9 cube by 3. Now what is this equation? This is the equation of deflection. Okay, Right here, this is the equation of deflection, and this will our second equation. And next step, apply the boundary condition. Okay, right here, apply the boundary condition. Okay, anyone know boundary condition where is applied? Boundary condition is applied at support, particularly for overhanging beam. We have to take care, because look at this. This is our A point. Okay, this is our B point. This is C point, and this is T point. Okay, now at A point, first x is equal to 0, then y is equal to 0, and this is the equation of x and y present in equation number 2, deflection. Okay, at A point x is equal to 0, y is equal to 0. Okay, again we put these values in equation number 2. What is the answer of constant C2? That is 0. Right here, C2 is equal to 0. Now apply the boundary condition at our second support. Now here we take care, because look at this. This is support A and this is support B. Okay, A support, this is B support, and D is our free end. So first value we take it A point, x is equal to 0, and students are taking second boundary condition at D point. But remember that at D point is free end and our support is given at B point, so that in overhanging beam, when we take a boundary condition, we take at B x is equal to 9. Okay, because at B point support is given, so that x is equal to 9 meter and y is equal to 0. Now put this value in equation number 2, one by one. Okay, EI, y is equal to 0. Second number, minus 76.12, 3 to just 6, and what is the value of x? That is 9 cube, plus C1 into x is equal to 9, and the constant C2 is equal to 0. Next, 5, 4 3s are 12, and x is equal to 9 cube, and plus, look at this, 30 by 3, that is 10, x is equal to 9, 9 minus 4 raised to cube minus 93.88 divide by 6, and x is equal to 9 minus 9 raised to cube. This last term is cancelled. Now after simplifying, we get value C1 is equal to 584.20. right here, C1 is equal to 584.20. okay, here we get constant C1 and C2. In next step, we find out slope and deflection at free end. Okay, now next, right here, we find out slope. First we find out, right down here, where is the point of slope and deflection? Slope at free end. Okay, again mention the point, A point, this is our B point, this is our C point, and D point. Now what is the distance at D point? 4 plus 5 plus 2, that is x is equal to 11 meters. So that take distance x is equal to 11 meter. Okay, now EI dy by dx is equal to, first our equation is equal to value of this dy by dx is equal to equation number 1, dy by dx, that is equal to minus 76.12 x square by 2 plus C1, then plus 5 x cube by 3, second 60 x minus 4 square by 2, and minus 93.88 x minus 9 square by 2, and value of C1 we find out, that is C1 is equal to 584.20. Now after simplifying this, right here, EI that is theta d, because we find out slope at free end, and free end the notation is d is given, so we take dy by dx is equal to theta d. Now put the value of x is equal to 10, 10, 10, this is 10 minus 4, 10 minus, all term we have to calculate here. After simplifying, answer is 520.49. Okay, now theta d is equal to minus 520.49 divided by ei. Okay, now what is the value of e? E is equal to 2 into 10 raised to 5 Newton per mm square, and I is equal to value of I is equal to 5 into 10 raised to 8 mm raised to 4. Okay, now remember that the value of theta d, unit of this theta d in numerator, that is kilonewton into meter square. Okay, minus 520.49 divided by e, 2 into 10 raised to 5, and this is I is equal to 5 into 10 raised to 8. Now this value is given kilonewton into meter square. So if we want to convert this kilonewton into meter square in Newton mm, or it may be possible ki we consider Newton mm and convert into kilonewton into meter, but in this case we convert this kilonewton into meter square in Newton mm. Okay, here in right hand side I convert this value, 1 kilonewton meter square, how much Newton mm? 1 kilonewton is equal to 10 raised to 3, 1 meter is equal to 1000, so 1 meter square is equal to 10 raised to 6 mm square. Okay, so that this conversion is equal to 10 raised to 9 Newton mm square. Put this conversion, 10 raised to 9. You remember that if E or value of E and I is given in Newton mm, we have to compulsory convert this value in Newton mm. Now theta d is equal to minus 5.2 10 raised to minus 3 radian. Okay, and this answer is minus, so can write anti-clockwise direction. Now second, find out deflection. Right here, deflection at free end. Okay, and free end again, what is the distance? X is equal to 11 meter. X is equal to 11 meter. Right here, E, I and y. Equation of our deflection is equal to minus 76.12 divided by 6 and x cube plus c1x constant c2 plus 5 by 12 x raised to then 30 x minus 4 cube by 3 and minus 93.88 by 6 and x minus 9 cube. Put x is equal to 11. After this simplifying, EIY is equal to minus 1040,880, and this value is in kilonewton meter cube, and this value is kilonewton meter cube square. Now y is equal to minus 104080 kilonewton meter cube divided by EI. One by one, kilonewton meter cube convert into Newton mm. Here I write down what is the conversion of this 1 kilonewton meter cube is equal to 1 kilonewton is equal to 10 raised to 3 Newton. Right here 10 raised to 3. 1 meter is equal to 1000 mm. So that 1 meter cube is equal to 10 raised to 9 mm cube. So that 10 raised to 12 Newton mm cube. Okay, next it is equal to minus 1040.80 into 10 raised to 12 divided by E 2 into 10 raised to 5, and value of phi is equal to 5 into 10 raised to 8. After simplifying, we get the answer is equal to minus 10.41 mm, and this is minus, so can we write sign of this reflection is upward direction. Okay, now our example of overhanging beam is complete. In Macaulay's method, first session we solve the example of simply supported beam, in second we consider moment, and third we take overhanging beam. In next section we take cantilever beam. Okay, and today's session we complete here.